Assalamu alaikum interclass. My name is Sarah Ahmed and I'm lecturer in physics. Today I'm here with the topic 16.15 transistors, or also called as bipolar junction transistor, which is actually known as BJT. BJT stands for bipolar junction transistor. Now before we move on to see how a transistor is made और इसमें current कैसे flow होता है, let's see what this word is made up of. This is made up of two words, transfer plus resistor. And bipolar से मतलब है, bi means two, polar means poles, like two poles, and by that it means we are using both electron current as well as hole current. Transistor की एक और identification है कि it is 3 electrodes होते हैं इसमें. How? So by 3 electrodes it means it has base, emitter and collector. Where you see B का मतलब is base, E means emitter and C means your collector. Now you see that base is always in the middle of emitter and collector, and base is the middle layer as well as it is lightly doped, whereas you see because it is lightly doped, तो आपके पास base is the thinnest layer of all these three. Then you have emitter. Emitter is heavily doped, that's why its layer is the widest of these two. And then you see collector, it is moderately doped. So these are the characteristics of any general BJT, and these can appear as your MCQs. KG, which of these three is heavily doped? You should know कि emitter is always heavily doped. Base आपके पास lightly doped होता है, that's why it is the thinnest of these two, and C is moderately doped. So first emitter होता है, ज़्यादा डोप्ड होता है, तो इसमें ज़्यादा चार्ज कैरियर्स होते हैं, इलेक्ट्रॉन्स या होल्स की तादाद ज़्यादा होती है. बेस में सबसे कम होती है और कलेक्टर में बेस से ज़्यादा होती है बट एमिटर से कम होती है. सो इन टर्म्स ऑफ डोपिंग वी कैन से के एमिटर इज हेविली डोप्ड, देन यू हैव कलेक्टर, एंड द स्मॉलेस्ट ऑफ ऑल इज बेस. सो इफ यू लुक फर्दर इन ट्रांजिस्टर, तो आपके पास ट्रांजिस्टर के मतलब बीजेटी के दो टाइप्स हैं, दैट इज NPN एंड सेकेंड इज PNP. और जिस तरह ये लिखा जाता है उसी तरह इसकी अरेंजमेंट होती है. इफ यू ट्राई टू डिस्क्राइब कि जी NPN किस तरह होता है, सो दिस शुड कम इन योर माइंड कि P टाइप इज सैंडविच्ड बिटवीन टू N टाइप्स, कि एक P टाइप होगा उसके साइड में दो N टाइप्स होंगे, एंड PNP इज एग्जैक्टली ऑपोजिट टू दिस. N type will be in the center, being sandwiched between two P types of our semiconductors. Now before we see कि इसके symbols कैसे होते हैं, let's try to see कि base, emitter, collector में से कौन सा NPN है. अगर हम इसको इसी arrangement में से लें, so that means, so if you look this figure, तो आपके पास for NPN, this is your P type, this is your N type, and this is also your N type. For PNP, the center one is your N type, this is your P type, and this is your P type. So base हमेशा बीच में होता है और दोनों में से कोई end emitter होता है, collector होता है. For NPN आपके पास P in the center means base, और PNP में आपके पास N is the base. Now let's see कि इसके symbols कैसे होते हैं. Let's see for our NPN first. NPN के लिए if you see कि आपके पास 3 electrodes हैं, this line over here, and then this end, and then this end. P is the center one, that means this is base, this is your emitter, and this is your collector here. Now you see कि emitter की यहाँ पे एक arrow है, and this arrow helps determine कि आपके पास NPN है या PNP है. Because if we see in our PNP transistor symbol, so you see कि for PNP आपके पास arrowhead is upwards, is towards the base, or for NPN it is outside, away from the base. So if it is away from the base, again let me just denote, this is our base, this is our collector, and this is our emitter. So आपके पास for NPN the arrowhead is away from the base, and for PNP the arrowhead is towards the base. This is the way to identify कि हमारे पास सर्किट में कौन सा ट्रांजिस्टर लगा हुआ है, आया NPN और PNP. Which thing determines? The arrowhead. So arrowhead not only determines कि आपके पास कौन सा type of transistor है, but it will also tell you कि आपके पास current flow किस तरह है from P to N. Now let's see, अगर हम PNP के लिए कहें, so from P to N type, our flow of current is going to be in this way. And for NPN, our flow of current from P to N, it is going to be this way. So जिस side पे arrowhead है, that determines कि कौन सा type है transistor का, but it also determines the direction of conventional current from P to N. Few other terminologies जो आगे काम आती हैं, एक तो this symbol, लेकिन अगर ये symbol है तो भी both are the same thing. अगर इस तरह का symbol होगा तो उस पर लिखा होगा कि जी कौन सा N है और कौन सा P है, लेकिन अगर इस तरह का symbol है so you have to determine कि arrowhead की direction कौन सी है, तो उस हिसाब से पता चलेगा is it NPN और PNP. Now let's say आपके पास कुछ terms हैं like base emitter, junction. Base emitter junction से मतलब क्या है? This one. This is your base emitter junction. Another term that usually occurs is base collector junction. Base collector junction means this one. Okay, so let's okay, so first we are going to discuss our NPN कि किस तरह काम करता है. Two things to remember in NPN. कि base emitter junction is always forward bias and base collector junction is always reverse bias. कैसे? Let's see. Let's talk about our base emitter junction. That means this one over here. It needs to be forward bias. और forward bias की condition क्या होती है आपके पास कि P needs to be connected to the positive end of the terminal and N needs to be connected to the negative end of the terminal. So we connect it like this. Positive end, negative end. Right? Another condition, base collector junction needs to be reverse bias. That means over here. So this is our collector over here, N side. For NPN over here, इसको reverse bias करने के लिए we need to connect our N side towards the positive end of the battery. So N here is positively on positive terminal, and here the N which is working as an emitter is connected to the negative end. So with respect to base collector junction and with respect to in regards to this battery, आपके पास this base collector junction is reverse bias because P here is connected to the negative and N to the positive. As far as this is concerned, your base emitter junction is forward bias because P is connected to the positive and N is connected to the negative. This is very important to remember. So now, since आपके पास emitter is the widest layer and it is heavily doped as we discussed earlier, that means इसमें number of electrons, charge carriers बहुत ज़्यादा हैं. इसमें भी obviously electrons are the majority carriers because N type में majority carriers आपके पास electrons होते हैं, लेकिन emitter से कम है because this is the moderately doped layer. और आपके पास base has holes in majority, but here this is already very lightly doped, तो holes होंगे लेकिन वैसे ही कम होंगे because this is the lightest doped layer of these two. ठीक है. Now what's going to happen? आपके पास current going to flow from here. Electrons will be repelled due to the negative terminal. They will start to travel towards the P type. जैसे ही P type की तरफ move करेंगे, obviously ज़्यादा electrons हैं, तादाद ज़्यादा है तो ज़्यादा move करेंगे. They will find holes over here और ये जाके holes में diffuse हो जाएंगे. So Matli lead, एक lead लगी हुई है obviously जो connect कर रहे हैं इससे. So these will be traveling over here. Electron यहाँ से निकलेंगे travel होके, लेकिन एज यू नो कि यहाँ पे होल्स वैसे ही कम है, तो लेट्स सपोज अगर 10 इलेक्ट्रॉन्स आर कमिंग टुवर्ड्स द पी एंड दे ओनली फाइंड 5 होल्स ओवर हियर टू डिफ्यूज, तो 5 डिफ्यूज हो जाएंगे एंड द रेस्ट ऑफ द 5 विल मूव टुवर्ड्स योर collector end because there are not enough holes for these electrons to be diffused. कम होल होने की वजह से जो इलेक्ट्रॉन्स रह जाते हैं वो यहाँ पे कलेक्टर एंड की तरफ मूव होते हैं. क्यों मूव होते हैं? बिकॉज यहाँ पे पॉजिटिव टर्मिनल है जो कि इलेक्ट्रॉन्स को अपनी तरफ अट्रैक्ट करती है, तो जो भी रिमेनिंग इलेक्ट्रॉन्स है दे विल बी अट्रैक्टेड टुवर्ड्स द कलेक्टर और वो कलेक्टर की तरफ मूव हो जाएंगे. सो यू सी आपके पास 3 तरह के करंट है. यहाँ से जो करंट फ्लो होता है उसको हम कहते हैं IE, that means emitter current. Emitter current goes in, some of the emitter current comes out in the form of IB and the rest of the emitter current comes out in the form of IC. So we can say कि इसकी equation हम बना सकते हैं इस तरह कि the entire emitter current, that is IE, is divided into 2 further currents. That is our IB plus IC. This is your equation for NPN transistor. So let me repeat it again. IE goes in, electron will be repelled because आपके पास battery connected है, electron will start to move here. We call that as our IE. When they move there, they will find holes. They will diffuse in our P type. But since there are not enough holes, तो सारे इलेक्ट्रॉन जो वहाँ से ट्रेवल करके आ रहे हैं सारे के सारे यहाँ पे डिफ्यूज नहीं होंगे. जो डिफ्यूज होंगे दे विल स्टार्ट टू मूव टूवर्ड्स द लीड और आपके पास इलेक्ट्रॉन विल बी मूविंग हेयर. लेकिन इलेक्ट्रॉन्स जब यहाँ से निकलेंगे IB, दे विल बी मूविंग आउट एज योर फ्री इलेक्ट्रॉन्स. यहाँ पे दे आर ट्रेवलिंग एज वैलेंस इलेक्ट्रॉन, यहाँ पे मूव होंगे एज फ्री इलेक्ट्रॉन्स और जो पीछे होल्स रह जाएंगे वो होल्स इस तरफ मूव होना शुरू हो जाएंगे बिकॉज दीज आर पॉजिटिव एंटिटी और वो अट्रैक्ट होंगे नेगेटिव टर्मिनल की तरफ. जो रिमेनिंग इलेक्ट्रॉन थे N से जो आ रहे थे कुछ तो डिफ्यूज हो गए, बाकी जो रिमेनिंग है N की तरफ मूव होंगे, दैट मीन्स कलेक्टर एंड की तरफ, पॉजिटिव टर्मिनल की तरफ, एंड दैट विल अपीयर एज योर IC. देन दिस करंट विल अगेन कंबाइन, विल स्टार्ट टू फ्लो इन फॉर्म ऑफ IE, डिस्ट्रीब्यूट हो जाएंगे, कंबाइन होंगे एंड देन दे विल फ्लो. From this working of our NPN, we form this equation, very easy straight mathematical equation that says that IE is equals to IB plus IC. Equation में you see that IE actually refers to emitter current, IB refers to base current and IC means your collector current. एक और जो important equation होती है for your NPN or transistor, and that is your beta is equals to IC over IB. Current gain कितना हुआ that determines your this के IC divided by IB. This is a ratio of similar quantities. So इसका कोई unit नहीं होता because amperes, इस current का भी amperes है, इसका भी amperes है, so ampere ampere cancel हो जाता है. कभी भी दो similar physical quantities का अगर रेशियो होता है तो उनका कोई भी यूनिट नहीं होता. सो दिस इज योर बीटा डीसी करंट गेन दैट डिटरमाइंस मैक्सिमम आउटपुट करंट देगा. सो दिस इज 2 मेन इंपॉर्टेंट इक्वेशन फॉर योर ट्रांजिस्टर एज एन NPN वर्किंग. नेक्स्ट इज PNP ट्रांजिस्टर. सो फॉर PNP आपके पास बेस एमिटर जंक्शन हैज टू बी फॉरवर्ड बायस एंड BC, दैट इज a base collector junction, needs to be reverse bias. Let's see, your base emitter junction is this one. Let's try to make this our forward bias. That means N needs to be connected to negative terminal and P needs to be connected to the positive terminal. This is what we did. Now let's come to the BC collector, junction, BC junction that needs to be reverse bias. That means P को reverse bias करने के लिए हमें इसको negative terminal से connected करना है. So we connected our P to the negative end and N of this battery terminal positive end. So base collector junction is reverse bias, base emitter junction is forward bias. That means this is positive terminal here because of the battery and this is negative terminal here because of the battery. Right. Now let's see आपके पास P में majority carriers क्या हैं? Holes. holes are the majority carrier in P, and since emitter is heavily doped, so you have lots and lots of holes in here. As compared to your N type over here, this is very lightly doped, and although electron are the majority carriers in N type, but ये lightly doped होने की वजह से electrons की तादाद यहाँ पे कम है. Then again your P type collector, this is doped but not as heavy as emitter, so there will be holes but not as much as your emitter. So let's see it's working. आपके पास यहाँ पे positive terminal है, that means holes will be repelled from this end because of the positive terminal, and holes, they work as positive entity. They will be repelled and moving towards your across this junction towards the N type, that we call as our IE. Again same as that. Now these holes will find electrons over here, और holes यहाँ पे आके diffuse हो जाएंगे with your electrons, and they will find their way out towards this metallic lead, और यहाँ से they will come out in the form of your what? IB, that means base current. Then you see कि this is very lightly doped. अगर आपके पास यहाँ से again 10 holes say, they only found what? 3 electrons. This is just an example, obviously this won't be like that. Lekin just to give you a number to help give an illustration. So you have what? How many holes left? 7 holes left. They will find their way towards the BC junction, that is base collector junction, because of the negative terminal here, और वो attract होंगे towards the collector end because of this negative terminal, and they will find their way out over here in the terms of IC, that means collector current. Now you see again you had the same thing. IE got in the device divided in 2 branches, that is IB and IC. Hence we can write that IE is equals to IB plus IC. From this equation we can easily conclude that IE is greater than IB and IC because it is the summation of these two current. Then again आपके पास beta DC gain for this is also IC over IB. These are important 2 equations, and most of the numericals or problems of transistor, they rely on these 2 equations. So that is about it for our transistor. 2 types, NPN and PNP, which is heavily doped, lightly doped, and which junction is forward biased, reverse biased. This is all explained in this video. If you have any questions, please feel free to comment down below. Looking forward to your questions, and the next topic will be your transistor characteristics. That will only be about the graph of your transistor, input graph and output graph. So till next time, stay safe and stay home. Take care and Allah Hafiz.